Okay, so looking at number 8 here. So the problem refers to the component of this vector. We've got some vector x. We want to look at the component of the vector x in the direction of some standard basis vector. Now, this x is known to be a three-dimensional vector, coordinates x1, x2, x3. Well, we have a formula for component. The component in the direction of, and let's say, I'm going to say EI here. Now, so that it could be E1, E2, or E3. Right? Yeah. So component in the direction of EI of the vector x, well, the formula is we take x dot EI, and then we divide by the length of EI. Of course, EI is a standard basis vector. It's like all zeros with a 1 in some position, so the length of that is equal to 1. So in fact, this is just equal to the dot product. So that's that's our first part of the problem. And by the way, let me just remind you, this is a cool interpretation of dot products. A dot product, in particular, because this is a unit vector.
Yes.
Dot product is the same as the component of that vector in the direction of that unit vector.
Okay.
And this is that cool. So this is in the book there, a couple pages back. But this is a cool interpretation of dot products in the special case that one of the vectors is a unit vector, because that becomes a 1, and the formula for component ends up being effectively a formula for dot product. Okay, that's just a little tangential remark there. But okay, so let's finish this up now. Now, what is this? X dot EI. Well, it depends on what EI is. There's 3 of them, and you got to write them all down. So in particular, x1, x2, x3 dot E1 is, well, let's see here. It's x1, x2, x3 dot, well, let's see, what is E1? Well, it's 1, 0, 0. And this is an easy dot product. It's just x1. So the component in the E1 direction is that dot product, which is x1, which is the coordinate in the it's the E1 coordinate of the vector.
Yes, sir.
So the component is that coordinate. Now, likewise, what happens if we're looking at x dot E2? In other words, what if we're looking at the component in the E2 direction? Well, it's going to be x1, x2, x3 dot E2, which is 0, 1, 0. That's also an easy little calculation. That's x2. So the component in the E2 direction is the second coordinate of the vector. And likewise for E3, and I'll let you fill in that blank, but it's the same, morally the same calculation.
Just a little tangent. So how do you show like operation, like the dot product operation using that notation? Like, say it was like x dot w, and it was 2 different numbers. Because like when you do it in the long form, you have to like multiply the product.
Yeah, you multiply and add. I mean, we got lucky here with this formula with the dot product, because we happen to have some zeros. We love zeros, right? Okay. So this happened to compute nicely. But yeah, if you have like x1, x2, x3 dot, and if it's like w1, w2, w3, you just got to write it all down.
That's what I figured. Okay.
It's There's a lucky break here for sure.
Okay.
Yeah, absolutely. Let me stop this.